tutorial on installing and using Anaconda. So to install Anaconda, I'm using a MacBook in here. So the instructions to install it and use it on Microsoft Windows should be similar. So I started by going to Google. From Google I searched for Anaconda download. So there are two versions of Anaconda. There is a commercial version that you can use like it's a license, institutional license, and there is an individual license that's non-profit and you can use for your for the sake of your classes. So I typed on the search Anaconda download, and the first link that you see in here says www.anaconda.com products and individual. I click at this link and it will take me to the download page. If you scroll down within this download page, excuse me, you should be able to see this download. I click at download, it scrolled all the way down and it takes me to Anaconda installers. So as you can see in here, we have three versions of Anaconda, three main operating systems that you can install Anaconda on top of. The first one is Microsoft Windows, the middle one is MacBook, and the last one is Linux. If you are a Windows user, we need either the 64-bit graphical representation or a graphical installer, or the 32-bit graphical installer. Please do not install the 2.7. I highly recommend you to go with 64-bit graphical installer if you use Microsoft Windows. Similar to my machine, I'm using Mac OS, so I'll go, and my operating system is 64-bit graphical 64-bit. So I'll go with this one with the graphical installer. So when you click at it, it will start the downloading for you, and it will take some time. But because to save some time, I installed it on my machine, and it's up and running. It's a direct installation. All of what you need to do is just a few next install it for yourself, and you should be able to install it at your machine. Once you are done the installation, if you use Microsoft Windows or Mac, you can go and search for Anaconda, and what we will run is the Anaconda Navigator. So I selected Anaconda Navigator, and this immediately opens Anaconda for me. So this is the default page that will run and open for you. So it will open Home, Anaconda, and you should be able to see in here base root. So Anaconda has a cool feature where it creates set of environments where each environment is independent from other environments, and this is very useful if you would like to run a different Python version in each environment, if you would like to install packages with different versions so you avoid any type of contradiction or confusion, and mainly the contradiction between versions or between libraries versions and prerequisites for each library. So I would like to create environments and separate each experiment or each project in a separate environment, and that environment includes all the prerequisites and packages that are, when I talk about packages, I mean by packages libraries, any package or library that's required for that project. So to start creating environments, whenever Anaconda starts for you, you just go to environments. Excuse me. From environments, if you look all the way down in here, you should be able to see create. So this create is to create a new environment for you. There is clone, if you would like to clone an existing environment and add packages to it, or import an existing environment, or remove an environment that's currently selected. So I'll go ahead and select create. On create, it will give you a dialog box. It will ask you about what the environment name that you would like to create. So I like to add or create a name for my environment, a meaningful name for my environment, so I can use it and I can tell which is which. For instance, if you see in here, since we like for instance for a class of ECE 5995, I would just name it as ECE5995. Or if I would like to create an environment for instance, TensorFlow 2.0, so it will not accept points, so I'll go with underscore. So this is TensorFlow 2.0 or underscore O, and I would like to install Python 3.7 on this one. So you can see in here my name, or the name that I use, is something that indicates what this environment is created for. And TensorFlow is a deep learning package that you can use for creating neural network methods and algorithms and models. Now, in Python, the version that I installed is the most recent one. The version of Anaconda that I installed is the most recent one up to today's day, which is June 29th, 2020. And if you install an older version, it will give you more options of what Python version you want to use. I highly encourage you to use the most recent Python package, unless you need to run an older package that requires an older version of Python. You can also install R if you are an R user, but for my case, I'll just go with Python 3.7, then hit create. That will take some time to create the environment. To save some time, I'll just hit cancel. I already created a package. So as you can see, there is one, like we have two packages. The one that comes by default is called base and root. This is the default the default environment. And there is this ECE5995 Python 37. So when you click at it, you will notice down in here it's loading some packages, and the packages that are installed with this environment. Now, once it loads all of the packages, and you see in here everything will be changed, I can run my code. So now it will show me what packages are installed and what packages I can install by looking at this drop down menu. So I can select installed, and whenever I see this check mark, that means this package is installed. If I would like to install a new package, I can type in here not installed, and then I can search for it in here. For instance, I would like to see Numpy. Numpy is already installed in here. However, it's not available within the default packages that you can use to install. So you can search for whatever package you would like to install. Let's look for TensorFlow, for instance. Let's look at Keras. It's not available in here. Let's look at all packages. OS, for instance, this is another package, and so on. So we will see in a few minutes how to install some packages using either this method or other methods. Now, I activated my environment in here. I would like to go and run like an IDE, integrated development environment, where I can write my code into and run it using Python, using the environment that I'm running, which is with Python 3.7 and any packages that I installed on this environment. So now there are multiple IDEs that comes with Anaconda, or you can install your own IDE, such as Spider, or if you would like to go with PyCharm, Sublime, or any other professional text editors or IDEs. For our prototyping code that we are running, I will install JupyterLab and Notebook. So I installed them before I started this video to save some time, but you should be able to see this green install button underneath them. So I already installed them, and I would like to run this JupyterLab. When I click at JupyterLab, it's like a new it's an upgraded version from Notebook. It opens the web browser for me, and immediately it opens this web browser, and I can either look up an existing file that I already have by browsing and looking at the files where I have my files saved at, or I can upload versions of files. For me, I already navigated to where my files are saved at. Double click at the file, it will open for you. Let's have a quick tour around Jupyter Lab and see what options are available for us. Initially, this is the working space that will show you which or what the file that you can edit. If you would like to close the file, you can just click at it. This will close the editor, but it will keep the Python code of that notebook up and running. As you can see in here, there is like a green dot in here, period, that indicates that my Jupyter notebook is still up and running. How can I see all of my Jupyter notebooks that are up and running? Each one in here is called Jupyter Notebook. So you can click at this tab, and this will show you all of the running applications or running notebooks that are up and running. So I'll shut it down to terminate it. I'll shut both of them down by clicking at this option. I'll go back to the this sidebar, and you can see the green line, the green light or the green dot has been removed. Let's double click at Python intro version 1, and it will take a few seconds to load, and because I have some code in there and I have some output. If you would like to create a new Jupyter notebook, you can hit Python 3 and Jupyter notebook from here, from the launcher, or you can open existing files, open other terminals. You can also install some plugins to Jupyter Lab that makes your debugging and running easier. But for the sake of this tutorial, I will not create or install any plugins, just to make sure that my Jupyter Lab runs fast. You can also create folders. If you added something or modified something, you can refresh your directory, and there are other tools that you can use to install packages and add-ons on your Jupyter notebook. Now, I have my Jupyter notebook up and running, and you can see in here, this is the file that I'm running. And we have file includes some information. For instance, you can download and export your Jupyter notebook as HTML, LaTeX, PDF. If you would like to present it somewhere and you wanted to make sure you include everything, all images, all output, and in case they do not have or the machine that you are presenting at may not have Python, you can save it as an HTML and open it, and you will not be able to run your code. However, you will be able to save all of your files and output. You can also download it as a file, Jupyter Notebook, or Python file. There are basic edit, undo, redo, select, deselect, delete cells, and so on. There is a view where you can show the sidebars. There is run to run selected cell. We will see it in a minute, a shortcut for running a certain cell. Now, your Python is running on top of a kernel. This kernel includes the Python as well as the packages. You can restart your kernel without restarting your Anaconda or without restarting your Jupyter Lab. So all of what you need to do is just hit restart the kernel, or if you are running a task and it's taking forever, you want to terminate it, interrupt it, so you can send this interrupt kernel signal to restart your Jupyter Notebook. If you would like to restart the kernel and clear all outputs, like you see in here, this cell is run and we have some outputs in here. If you would like to clear it and rerun it again and clear all output, you can just say restart and clear all outputs. You can restart it and reset the kernel and run up to the selected cell, or you can run or restart the kernel and run all of the cells. You can shut down the kernel, you can shut down all up and running kernels, and you can switch the kernel to a different kernel. There are other options, I will not go into them. These are the options that we need for the sake of our tutorial in here. So you can select also the Python and the kernel from this Python 3. You can click at it, it will show you the available kernels. You can select the kernel that you would like to run, select, and then select. Cancel in my case. I would like to hide this one so I can see it wider. So now, Jupyter Notebook, let's go into the work area and see what we can do within the work area. There are several nice features in Jupyter Notebook and Jupyter Lab. So I'm running Jupyter Lab now, but most of the options are shared between Jupyter Lab and Jupyter Notebook. In Jupyter Lab, There are cool features such as adding comments and some sort of heading and tutorials, headings that helps in creating tutorials and hints and guidelines, help how to run the code. And I will use Jupyter Lab to create quick tutorials and quick POCs, proof of concepts, a quick run simple code. But if you would like to create a complete project, I highly encourage you to use like a full IDE such as PyCharm or Spider. Otherwise, if it's just like what I do in here, quick tutorial, Jupyter Lab should be fine and perfect for this job. So as you see in here, I do have a cell. Each cell will include Python code, and you can run that cell per se. You do not need to run everything together. Just run that cell. It will save the state of that cell, move it to the next cell. So this will be part of the complete code. If you want to exclude part of your code from the whole program, you need to restart your kernel, make sure you clear the contents, and rerun the code again. Now you see there is text in here that doesn't seem I'm able to edit it. So if you would like, let's see first how to add a new cell. So I'm now at cell 3. To add a new cell, all of what you need to is click at this insert a cell below. This will create a new cell. It doesn't have any number, and this number, by the way, is the number that this cell ran, which sequence, what cells ran after which. We will see it in a minute. Now I created a cell. You can move your cell around, just clicking at it and just moving it around, down or up. And so I moved it up. I would like to move it all the way up in here. Drag it and drop it. You can type within this cell, such as you want to import a package such as Numpy. You can just say import Numpy as NP, for instance, and this will create Python code for you. Now I do not want to create Python code. I would like to add some just quick text guidelines, hints about what this page is all about. So you can convert this cell into one of 3 types. One is code, and the second one is markdown. If it's a code, you will see colorful code for or coloring scheme for your code, and if you convert it to markdown, it will be runnable as and like HTML generated in the backend. For instance, I converted this to markdown. If you would like to create a large font size title, you can use £1 like for instance welcome to Python or this is not Python tutorial, this is Jupyter Lab tutorial. And if you want to create a smaller font size, you just add 2 pound signs. So this is line 2. You can add 3 of them, line or level 3, and this is in fact level 2, and so on. So now once you are done, you can see that this is in the edit mode. If you want to make it in the view mode, you can run it, and to run this, all of what you need is just to click at this button, or you can click on or hold shift and then hit enter while you are selecting a cell, and this on the keyboard is a shortcut to run your cell. So I created this cell. I would like to edit it. To edit it, just double click in it and this will edit it for you. I would like to add this is a tutorial to go over Python, for instance, and I can edit it now by either hit run or shift return or shift enter. This will run the cell for me. Okay, so now this one is done. You can edit this one as well by just clicking double click within the cell, run it, and this is up and running. Let's start with a quick tutorial in Python using Jupyter Notebook and or Jupyter Lab. Initially in here I would like to create a variable, and the variable I will name it as nums and initialize it to the range of 100. So this range of 100 will save the values from 0 to 99 inclusive within the variable nums in the form of a list or what's known as an array. Then I created an empty array by typing the name of the array and then equals and empty brackets, and this will create an empty array so I can use it later on within my code. So in the following code there is a for loop, and this for loop is to read the values one by one. Read each value in nums, save it in num, and then take this value and multiply it by itself, or take the square of that value by just saying num times 3. That means num times num. So this is a square. So it's num times num, or num square root. So this is num square, squared. Num times num. So take each num and multiply it by itself, or take it to the power of 2, and then take the result and append it to squares, which is the list that we created on top in here. So it's dot append, and this will append the values, the square values from the square values from 0 up to 99 inclusive. So if we run this cell, I hit shift enter, and this is cell 1 in terms of running. It ran the first one. Then I went to the second one to print the contents and see what I have within this list squares. So I typed its name and then shift enter, and this ran it and shows me the results of this square. As you can see in here, it's the square of values between 0 to 99. Now if you have more values, you can just point to the left edge in here and just collapse the results. You should be able to see it in the form of 3 dots if it's collapsed. Now I do not recommend you to include a lot of output within your Jupyter notebook, because that will increase the size of your Jupyter notebook, and if the size is large, it might crash. So therefore try to make your output minimal within the same screen. So sometimes you will see in here, I'll just display the output and then remove it. Now I would like to remove this output as well as this cell. So you can just click this pair of scissors, and this will cut the cell and remove it from the Jupyter notebook. You can paste it later on if you would like to, but for myself, I do not want to keep it. I'll just cut it and remove it. In the second cell, which is, or the following cell, it has the number of 6 because I ran it before. I created the similar example where I created nums, and I put the range from 0 to 99 inclusive within nums, and instead of using a for loop, there is a shortcut or cut for using the for loop within a list by saying for num for each variable in a list of variables or an array, just perform some sort of operation and enclose all of that between these square brackets, and the results will be a list that will be saved in the left hand side. Now if I run it, it will take cell 3, so we have 1, 2, it was already deleted, I have 3. Now if you would like to run it again, you just modified this one, you can go back and run it again, and it will take the next value, which is 4. This one is already 3, you can keep it and skip it and go to the next cell. This cell, we created a range from 0 to 99 again, and we would like just to retain any root or the root of all odd values. So between 0 and 99, and I selected each value, so for num and nums, for each value within the list of nums from 0 to 99, if the value mod 2 equals 1, that means this value is odd. If it's an odd value, find the square root, square it, and then append it to odd squares. Similarly, I ran it, and all of these odd squares have been saved within this list. Let's run it and see what results we have. We have 1, 9, so 3 times 3 is 9, 5 times 5, and so on and so forth. Then we have all of the odd squares. Similarly, I'll remove this cell because I do not want to increase the size of my Jupyter notebook. Now, we can do similar or the same operation in here in one single line, and that should be faster because it has room for parallel. For loops mostly are not parallel, but if you try to go with this shorthand, sometimes it's faster. Num is the range from 0 to 99, and then we calculated, we have a for loop that visits the nums in nums, and if the num mod 2 equals 1, it's odd, then return it square, and save all of that in odd squares. I will run it and you should have the same results, similar results to what you had from cell 5. Now let's move to a different data structure. So we have seen the first data structure, which was a simple array. We have also what's called dictionary in Python. Dictionary is a form of a hash table, if you are familiar with hash tables and data structures. So it has a key and value. So every key is associated with a value. It's saved using a hash function, so it should have a direct access. So if you have fairly medium-sized data and you would like a data set, you would like to access it quickly in the form of a key and value, I highly encourage you to use this dictionary or hash table to save your keys and values so you can access them quickly, especially if you do a lot of operations on the list. Okay, let's see how to do that. In this cell, we have the first line is creating a range again from 0 to 99. Then we would like to create an empty dictionary or an empty hash table by typing the name of the dictionary, followed by equals, and then the curly brackets to indicate this is an empty dictionary. Now, we would like to visit every single element within the list of from 0 to 99, find the root, and save it in the dictionary. The key value will be the num, and the value will be the square of that value. So now, we try to find, and by the way, Python is it follows the indentation for determining which what block belongs to what structure. So I was missing just a tab in here. So for num, in nums, if num is mod 2 equals 1, that means if it's odd, if the number is odd, then take the square of that number and save it in the hash table. The value will be the square and the key will be the actual number. For instance, in this example, the key will be 3 and the value will be the 3 times 3, which is 9. So just type it 3 times 3 to indicate this is the value. So this is the key and this is the value. And this is an example. It will take all of the odd values and save them in this format. So now, whenever I modify something, I like to save it. So as you can see, I got used to this habit to save everything continuously whenever I modify something, and unintentionally I saved it, and to make sure everything is saved so I do not lose anything in case my computer crashes or my browser crashes. Okay, so now let's run this code. It ran, and we should be able to see now the dictionary. Let's just have a quick look at the dictionary. So our dictionary is called odd dictionary. Run, and you should be able to see the list of keys and values. Now I do not want to keep this dictionary. Let's just delete it and go to the next one, and the next cell we are doing the same, but just using the shortcut of the for loop. You see in here we are enclosing all of our operations between these curly brackets, and everything else is the same, except that in this part we are setting the key colon the value that will be saved in that key. Now run, this will run it and save the same values in the odd dictionary, and hopefully that will be faster. Now Jupyter Notebook and Jupyter Lab include some sort of timing or some functions that help running or running some prototypes, such as timing a process. For instance, let's see how much time it will take to run finding the odd numbers, the square root of odd numbers in the range between 0 to 100,000, and this will be creating a range of 100,000. So this will be from 0 to 99,000. If the number mod 2 equals 1, just find the square of that value and save it within a list. So this is a list, it's not a dictionary. Let's run it, and it will show me the time, the CPU time, and the wall time to run that process. Now, let's time it again and see how much is the time for running this with more details. Time it, it will try to run the experiment and show you what's the actual time ran and how much time each loop took. So just some more details on the timing. I will not go into details but about this command in specific, but we are just trying to see some cool functionalities that you can find within Jupyter Lab and Jupyter Notebook. Now, let's see how to append the values using a for loop. Using a for loop, let's run it, and you see it ran within 17, so the wall time is 17 this is microseconds, 17 microseconds, where that one it was 66 milliseconds. Time it again and append the values, and let's see with time it how much time to take. It will try to find the upper and lower limits in terms of time. Takes some time. It took 76 milliseconds. There are other methods that you can use, such as whols, which will list all active variables in the namespace. You can run debug, reset, lsmagic, and so on. I will leave them for you to test them and see what they do. We have also scoping. So what we wanted to explain in here, we wanted to show you that if you run something within one scope, it will be moved to the second scope. And even this X is local within excuse me, within this F structure, it's also visible within the second cell. Okay, let's see how we import a package or library in Python. So in here, we are using Numpy. Numpy is a package that you can use for mathematics and running some mathematical models quickly and fast. To import it, we use import the package name and how we would like to use it within our code. Import Numpy as NP. So Numpy does not come installed by default on our machine or on our Anaconda, so we need to install it. To install it in here, you need to go to Anaconda and try to install it in the environment. So I'm running the environment, and this is our environment is up and running. You can go and search for it in all and then select it and install it, or you can go with the second option of select this small arrow and select open terminal, and this will open this terminal for you. Now let's just try to run it. That will not take time. This is open terminal, and open terminal will open the terminal for you. I would like to clear it, and now you can install whatever package you would like to on that environment. As you can see in here, there is a home directory. This is my MacBook, and it preceded by which environment I'm running from. So you can now type Python. Sorry, you want to install a package, you can install it using pep, then install, and we would like to install Numpy. So it's pep install Numpy, hit enter. I already installed the Numpy before I run everything in here, so it's already installed in here. But if you would like to install any other packages, you can, like for instance, you remember I tested Keras, it was not installed, so I can say pep install Keras, hit enter, and this should install it. It will take some time to install. If the package is not available in your default set of packages or set of in your package manager in the channels that you have, you can Google it and look it up on the internet and see how to install it on Anaconda. Take the command and just copy it and paste it in here. Okay, so Numpy is already installed on my machine in here, so I will run the import Numpy. So Numpy is available now within my environment. The tutorial that I have in here, it includes rolling like 5 dice and just see the results. I will not go into the details of the question. I will leave it for you to go over it. But in here, if you would like to see some information about a package or a command within a package, you can use the command help, then list the command name. So we are looking for, from Numpy package, we are looking at random and then uniform random number generator. So you can type help between parentheses numpy.random.uniform, run it, and it will show you help about that command. So this is very handy whenever you are using a package that you are not familiar with. Now in Numpy, for instance, you can create a list using one command and initialize that list with all zeros using np numpy.zeros 5. This will create a list of 5 elements and all of them will be initialized to zeros. You can also create like an array using Numpy. So np.array, this will create an array, and the contents will be the range from 0 to 5 or 0 to 4 inclusive. So it will include 0, 1, 2, 3, and 4. 5 values. And so on, and you can generate random values. This random uniform creates uniform or random values from a uniform distribution between 0 to 6. And this will print the results. We have another example in here. It will take the floor of random. So random uniform will create a floating point number, and you would like to take just the values as so floor. It will take the value above the value that you generated. Like for instance, if your random generator generated 0.1, the floor will make it as 1. If it generates, so this one will generate from between 0 to 5, like anything less than 6. So 5.5 or 5.6 or 5.1 will round up using the floor to be 6. Now, to print the size or the dimensions of your list, you will use dot shape. So dot shape will show you the size or the dimensions of your list, and you can print the list using just print. Unlike other programming languages, for instance, if you know C++, to print the list contents, you need to use a for loop and iterate over every single entry within your list to print them. Whereas in Python, you can just do print and the list, and it will print the contents of your list. You can also create two-dimensional array using Numpy. Like for instance, passing 2 parameters or a pair or tuple will create n-dimensional matrix or n-dimensional array within Numpy, and then you can fill it as you like. You can slice the Numpy array. Just select certain values from the Numpy array, certain columns, certain rows. I will leave it for you to go over a tutorial or some internet resources. There are a lot of internet resources about how to deal and play with Numpy, how to use Numpy arrays. Again, there are other examples in here on how to use Numpy. There is one cool thing in here I would like to show you, which is it's how to compare two values. Comparing two values or a variable with an integer value using doesn't equal or equals. So you can do that, like compare a list versus one element. So this will take every single element within y and compare it with a 3. If it equals a 3, it will display true. Otherwise, it will display false. As you can see in here, y is a list of 5 elements. The first 2 are 3s, and the middle one is not 3, and the last 2 are 3. You can create an array with the results. Just name it as numpy.nonzeros, y doesn't equal 3, and this will create a list with the Boolean values that you have seen before. These are again some examples on how to find, for instance, the maximum value within the counts or the minimum value if you would like to. And this is how to create a function within Python in general. So you use the keyword def and then the function name, the list of parameters if you have. If you do not have, you just open the parentheses and leave them open, leave them empty. Colon to indicate this is the beginning of the function, and the contents of the function must be indented to indicate this is within the function itself. As you can see, you can use f. You can use numpy maximum just to find the maximum of set of values, numpy array. You can return one value, multiple values, call the function from like append sentence, and so on. In here, I tried to run SciPy. So SciPy is another package that you can use. Like there is a statistics packages and statistical functions from this SciPy. So let's look at the SciPy. Do we have it in Anaconda? So I do not see it in here. You can try to install it with pip install SciPy. And if it's already available within the channels in Anaconda, you should be able to install it as you see in here. So SciPy is being installed, and once you are done, it should be available for you to use it from the Anaconda environment. Let's wait a little bit in here until it's done. You can also specify which version of the package you would like to install by just appending equals for instance, and write the package version that you would like to install. Now it's done. Let's go back to our Jupyter notebook. Sometimes you do not need to do anything, just continue running and it will be available as you see in here. And in some other cases, some packages, it will require you to install your kernel, restart your kernel to run it again. Now it's running, it's up and running, and the package is available. And you see in here this example, generate random values, and we have the mode comes from the SciPy stats, so you can import either a specific command or a specific function or a package from a certain package. Again, running the experiment for longer period, so you see this sum underscore v, because it's the indentation is incorrect, it's showing as red. So I fixed the indentation by just deleting the space and adding a different space. Similarly, in here we have other commands where we are timing each for loop, and other functions that tries to run with Numpy, multiple dimensional arrays, how to use functions, aggregating functions from Numpy such as sum, max, min, how to slice an array, how to change the dimensions of an array, and so on. So I will leave it for you. This is a quick tutorial on how to use Jupyter Notebook and Jupyter Lab or even Jupyter Notebook. In the following tutorial, we will talk more about machine learning and how to use Jupyter Notebook in machine learning methods, and how to code machine learning methods and or machine learning applications and models using Python. And most likely we will use either Jupyter Notebook or Jupyter Lab. Thank you, and see you in the next video.